Here is a provable fact. Australia has been trying to kill things for 200 million years, and it has gotten very good at it. Not just with venom, not just with teeth, with physics, with chemistry, with geology, with the atmosphere itself. The continent separated from the rest of the world long before mammals had figured out what they were doing, and evolution here kept working in isolation, answering questions that nowhere else was asking. Most people carry a short list when they think about Australian danger: snakes, spiders, sharks. That list is accurate as far as it goes. It just doesn't go very far. Beneath it lies a different category of threat: things that leave no bite mark, things you cannot chase away or kill, things that operate at scales a human nervous system was never designed to process. 13 entries, one selection criterion, documented reality that exceeds anything a reasonable person would invent. A crater punched into the landscape by an iron meteorite releasing energy equivalent to a nuclear detonation. A cloud formation 1,000 kilometres long that rolls across a gulf every September on a schedule you could set a calendar by. A Jurassic-era tree that drops 15-kilogram cones from 30 metres up. A fungus that bleeds. Waves 4 stories tall arriving on clear days with no warning and no meteorological explanation that satisfies a layperson. The reason these phenomena exist here and not elsewhere is the same in every case: isolation. 200 million years without interference. Evolution running unchecked. Geology accumulating without interruption. Atmospheric conditions developing patterns found nowhere else on the planet. Australia did not adapt to human presence because humans arrived, in geological terms, approximately 5 minutes ago. The list opens not with a crater or a wave, but with a plant. It doesn't kill. What it does is force living people to spend hours searching for words to describe a pain that outlasts every painkiller, persists for months, and defeats the vocabulary of every language that has tried to name it. That is documented. That is measured. That is where this begins. One of the most violent events in Australian prehistory left almost no trace, and that is precisely what makes Wolfe Creek Crater so unsettling. Number 13 on our list sits in the Tanami Desert of Western Australia, a place so remote that sealed roads do not reach it, and during the wet season it becomes completely inaccessible. Yet what happened here roughly 300,000 years ago reshaped the landscape in an instant. An iron-nickel meteorite weighing approximately 50,000 tons struck this flat red plain at around 15 kilometres per second. The energy released was comparable to a nuclear detonation. In fractions of a second, bedrock melted and vaporized, debris scattered for kilometres in every direction, and the impactor itself was almost entirely consumed, obliterated by the same collision that carved its mark into the earth. What remained was a crater 880 metres across, with a rim rising roughly 25 metres above the surrounding plain, its walls now softened by sparse desert scrub. From above, the structure looks deceptively calm, almost decorative, a neat circle pressed into the ochre landscape. From the ground, standing on that low rim and looking inward at the flat basin below, the silence feels earned rather than peaceful. Twisted, fusion-crusted fragments of the original meteorite are still recovered in the surrounding area, crumpled relics of the impact. Aboriginal peoples knew this site for thousands of years and regarded it as sacred ground. Western science did not formally study it until the middle of the 20th century. Since then, it has become recognized as one of the largest and best preserved meteorite craters on Earth, and, in a darker register, as the filming location for one of Australia's most chilling horror films, a choice that needed no special effects to justify the atmosphere. From number 13, a scar pressed into the earth, we move to number 12, a phenomenon written across the sky, the morning glory. A cloud 1,000 kilometres long rolls across the sky, and no one is sure exactly why it exists. That is not poetry. That is September over the Gulf of Carpentaria, and it is number 12 on our list. The morning glory cloud is a rotating horizontal cylinder of bright white vapour travelling due south at around 60 kilometres per hour at heights between 100 and 200 metres above the red Australian Earth. It is the largest atmospheric roll cloud documented anywhere on the planet, and it appears with predictable regularity over a single remote town, Burketown, in the far northwest of Queensland. The physics behind it are understood only in outline. At night, air cools over the dry land of Cape York Peninsula. Sea breezes flowing in from opposite coasts converge above the Gulf, collide, and instead of producing a storm, they generate a density wave, a soliton, that propagates through the lower atmosphere without breaking down. As it moves, it compresses moisture into a geometrically precise cylinder that rotates on its own axis like a slow horizontal turbine. The phenomenon sometimes arrives in multiples, 2, 3, even more rolls following one behind the other, like swells crossing an ocean made of air. Indigenous Australians have known this event for thousands of years. Their name for it is Kangolgi. Scientists with modern instrumentation still cannot model its formation with full accuracy. What draws people to Burketown every austral autumn is not research alone. Glider pilots fly in from across the world to ride the powerful updraft that runs along the cloud's leading edge, soaring hundreds of kilometres without once starting an engine. The morning glory is not dangerous. That is precisely what makes it so hard to process. 1,000 kilometres of rotating cloud over an empty landscape is not a disaster unfolding. It is something closer to a demonstration. Nature operating at engineering precision on a scale that removes any useful human reference point. What follows on this list adds the element that is missing here: genuine mortal danger. The Pinnacles were formed not by catastrophe, but by patience, and that, somehow, makes them stranger. Number 11 on our list. Spread across several square kilometres of Nambung National Park, roughly 200 kilometres north of Perth on Australia's west coast, thousands of limestone spires rise from bright yellow sand. Some are barely knee-high, others taper to a sharp point 5 metres above the ground, like the teeth of something enormous buried almost entirely beneath the surface. The process that created them began millions of years ago on the ocean floor. Shells from marine mollusks accumulated over vast stretches of time. When the sea retreated, those shells decomposed and saturated the soil with calcium carbonate. Rainwater, filtering down through an acidic layer of humus, dissolved the limestone in certain areas while depositing it in others, building dense vertical cores from the inside out. Wind then stripped away the loose sand surrounding these cores, and what remained were the spires visible today. It took tens of thousands of years. No eruption, no impact, no single dramatic event. Just chemistry, water and wind, working in the same direction for longer than our species has existed. The result is a field that the human brain consistently refuses to file under the category of nature. 17th-century Europeans who first encountered the site were certain they were looking at the ruins of a lost city. That instinct still fires today. The spires resemble gravestones, broken columns, the exposed bones of a buried architecture. At dawn, long shadows turn the field into a maze of dark shapes. By noon, the stone glares white. At dusk, the whole landscape shifts into ochre and deep red. The Pinnacles are not dangerous in any conventional sense. No venom, no teeth, nothing that moves. Their threat is subtler, the threat of absolute scale, absolute silence, and the persistent feeling that whatever this place once was, it ended a very long time ago. A living tree can be a murder weapon. That's not a metaphor. Number 10 on this list is the curtain fig tree, a giant strangler fig, Ficus virens, growing on the Atherton tablelands in Queensland. And what you're looking at when you stand before it is the aftermath of a slow, methodical killing that unfolded over decades. The mechanics begin with something almost mundane. A bird or a bat ate a fig somewhere in the canopy and deposited the seed high in the fork of another tree. The seed germinated up there, far from the ground, and the young fig began dropping aerial roots downward, feeling for soil. That's the moment the host tree's fate was sealed, though the host wouldn't know it for years. Once those roots reached the ground and anchored, the strangler started diverting water and nutrients away from its host, gradually closing the canopy above it to cut off sunlight and tightening its root network around the host trunk until the pressure became fatal. The host tree died, then rotted, then vanished entirely, leaving a hollow column of empty air inside the fig's living architecture. A tree built around the absence of a tree. What makes the curtain fig exceptional, even among strangler figs, is its geometry. The host tree apparently began to lean at some point during the process. That lean forced the fig to send out a second wave of aerial roots at an angle rather than straight down, and those angled roots formed the defining feature of this place, a near vertical curtain of interwoven brown tendrils, roughly 15 meters tall, hanging in the humid green dark like something from a nightmare. The impression is unmistakable. This looks deliberate. It looks patient. The tree is protected. There's a short walk from near Yungaburra, and once you've stood in front of it, you understand why. From this slow suffocation deep in the rainforest, we move to number 9, and to a spectacle of completely different proportions. Water that turns suddenly, shockingly, the colour of blood. The ocean off Sydney doesn't need a storm to become dangerous. On a calm morning, with no warning and no weather event to explain it, the water at Bondi Beach can turn the colour of dried blood. That is number 9 on this list, and it has a deceptively simple cause. A single-celled organism called Noctiluca scintillans. This marine dinoflagellate is not technically an alga, but it behaves like one gone wrong. Under the right convergence of water temperature, dissolved nutrients and coastal currents, Noctiluca colonies reproduce at explosive rates, reaching densities so extreme that they physically stain the water a deep burgundy red. The transformation is not gradual. One day the harbour is normal, the next it looks like something bled out into it overnight. Sydney residents have woken to this sight multiple times, and it never stops being unsettling. Tourists photograph it from the cliff tops and assume something catastrophic has happened. They are not entirely wrong. Here is the paradox at the heart of this phenomenon. The same organism that makes the sea look like a wound also makes it glow. After dark, the red tide becomes a light show. Every wave that breaks, every hand that moves through the water triggers flashes of neon blue bioluminescence. The effect is genuinely beautiful. The biology is considerably less so. Noctiluca does not produce the classic shellfish toxins associated with red tides elsewhere in the world. But when its cells die en masse, they release ammonia at concentrations high enough to burn skin and irritate mucous membranes. Swimmers come out with rashes. People with asthma or sensitive airways experience coughing fits just from standing near the shoreline. Fish suffocate in blooms because oxygen levels in the water collapse as the organisms decompose. Beaches close officially. This is not a one-off disaster. It is a recurring signal from an ecosystem under sustained pressure at the edge of Australia's largest city. And if the red tide hides its threat beneath an almost supernatural beauty, the next entry on this list buries its danger somewhere far less obvious. Deep inside a forest, in what most people would consider the most harmless form of life on Earth. The most unsettling things in the Australian bush don't move. They don't chase, don't sting, don't bite. They simply exist. And that stillness is precisely what makes them so deeply wrong. Ranking number 8 among Australia's most disturbing natural phenomena, 2 fungi have earned their place not through venom or aggression, but through something far harder to shake: the appearance of a crime scene quietly pushing through the forest floor. Hydnellum peckii, the bleeding tooth fungus, produces drops of bright red liquid across its white, velvety surface. The mechanism is guttation. When soil moisture is excessive, the fungus expels water through pores in its tissue. That liquid, however, carries compounds with anticoagulant properties related to atramentin. The result is a substance that matches fresh blood in color, viscosity, and the way it pools on pale flesh. There is no wound. There is no animal. There is only a small, silent fungus bleeding into the pine needle carpet of southern and mountain forests across Australia. The visual logic of injury is fully present. The injury itself is not. Clathrus archery, the devil's fingers, operates on a different kind of dread. It begins underground as a white egg, unremarkable and buried. Then it ruptures. Between 4 and 7 vivid red tentacles push upward through the soil, reaching like fingers from a hand dragging itself out of the earth. Their surface is coated in gleba, a dark spore mass that smells precisely like rotting flesh. That smell is functional. It attracts flies, which carry the spores and complete the reproductive cycle. The species arrived in Australia most likely during World War I, transported in wool or contaminated soil, and has been spreading through the country's ecosystems ever since. Neither fungus harms you on contact. What they produce is not physical danger, but cognitive dissonance. Living matter performing death with an accuracy that only millions of years of selection pressure can explain. The forest floor presents evidence of violence that never occurred. And if the fungi disturb by looking like something they are not, what lives in the waters off Sydney disturbs for the opposite reason. There, water itself stops being water. Most people who die at the Gap were killed on a beautiful day. That single fact tells you everything you need to know about why this place ranks 7th on Australia's list of deadliest hazards. The Gap is a sea cliff on the southern tip of Sydney's Cape Watson. The rock shelves drop roughly 20 metres straight into the Pacific. On any given morning, it looks like a postcard. Brilliant sky, white foam, a clean horizon. Tourists walk to the edge, they take photos. The water below appears almost still. Then it isn't. The waves that kill people here are not produced by local weather. They are born hundreds, sometimes thousands of kilometres away in the open ocean, where multiple swell systems with different wavelengths and periods travel simultaneously across the surface. When their crests align in phase, the amplitudes combine. A wave that was 2 or 3 metres high seconds ago becomes a wall of water 10 to 12 metres tall, roughly the height of a 4-story building. Physicists call this constructive interference of wave packets. There is no visual warning, no sound, no change in sky or wind that a person standing on the cliff could read. The local geology sharpens the effect. Submerged rock shelves focus and accelerate wave energy, directing it into narrow stone channels with the precision of an optical lens. The exposed rock surface is coated in algae, the grip of wet glass. A person caught in that surge cannot hold on to anything. Decades of accident records at the Gap and neighbouring sites like Bondi and Cape Solander confirm the same pattern. The victims are disproportionately tourists, drawn to the spectacle, unaware that a calm surface is not a safe surface. Warning signs exist. They don't solve the psychological problem. A threat you cannot perceive on a sunny afternoon does not feel real, and that is exactly what makes constructive wave interference so dangerous in a place like this. From here, the journey moves inland and upward into the forests, where the danger doesn't rise from below but falls from above. Number 6 on our list is a tree. Not a predator, not a venom delivery system, not something that moves. Just a tree. And that, in many ways, makes it worse. The bunya pine, Araucaria bidwillii, has been standing on this continent since the Jurassic. Long before the first mammal drew breath, these trees were already here, already growing, already doing exactly what they do now. 30 meters tall, dark, symmetrical, almost architectural in the way the branches push outward in horizontal tiers. In the parks of Brisbane and across Queensland, they look almost ornamental, planted along pathways, offering shade, looking for all the world like something that belongs in a botanical garden. That impression is a mistake. High in the canopy, something is quietly building. The cones of the bunya pine are among the largest produced by any conifer on Earth. The size of a football, up to 15 kilograms. They hang suspended 25, sometimes 30 meters above the ground, and when they're ready, they fall. No wind required. No warning sound. A calm, still afternoon, and suddenly 15 kilograms of dense organic mass is dropping from the height of a 9-story building. The physics are not complicated. The outcome is. Queensland parks now carry official warning signs during cone season, which runs roughly from January through March. Council workers cordon off the ground beneath mature trees. Local authorities have, more than once, seriously debated removing urban specimens altogether. Because the cones don't aim, they don't signal, they simply fall, and whatever is beneath them at that moment is simply beneath them. The Aboriginal peoples of Queensland understood this long before any council meeting. The bunya nuts were sacred, a seasonal food that brought tribes together for great gatherings. But those gatherings came with knowledge passed down across generations. You wait for the cone to fall, and you keep your distance from the tree while it does. The tree looks peaceful. It looks ancient and calm and permanent. And it is all of those things. It is also, without malice or awareness, one of the most quietly dangerous organisms on this continent. Beauty here does not mean safety. Shade does not mean shelter. And silence in Australia has never once meant nothing is happening. One of the most recognisable skylines on Earth vanished completely on the morning of September 23rd, 2009. Not obscured, not partially hidden. Gone. The Sydney Opera House, the Harbour Bridge, the entire coastal silhouette of Australia's largest city was swallowed by a wall of red. This was Red Dawn, and it remains the most severe dust storm in modern Australian history. The front stretched over 1,000 kilometres wide and carried an estimated 2 to 5 million tonnes of dust per hour as it swept toward the coast. Streetlights couldn't penetrate the haze. Road visibility in places dropped to a few dozen metres. The Opera House's iconic white shells turned the colour of rust. The air itself was dangerous. Particulate concentrations reached hundreds of times above safe thresholds. Thousands of Sydney-siders sought emergency medical treatment for respiratory distress, and the airport scaled back operations. What made this catastrophe possible was not a single dramatic event, but the slow accumulation of years. The inland regions of New South Wales and Queensland had been locked in sustained drought. Vegetation that would normally anchor the topsoil had degraded and retreated. The surface layer of the earth dried, crumbled, and fragmented into fine particles rich in iron oxides, the chemical signature that gave Red Dawn its almost Martian palette of deep copper and blood red. When a powerful cold front swept across the continent, there was nothing left to hold the land in place. The atmosphere simply lifted it. Sydney received the bill for years of slow environmental deterioration in a single morning. The storm didn't stop at the city limits. It pushed through Brisbane, reached the coastline, and scattered Australian desert across the Tasman Sea. Satellite imagery tracked the plume, extending thousands of kilometres over open ocean. Red Dawn sits at number 5 on the ranking of the most extreme natural events in Australia's recent history, and the reason is precise. It combined geological, climatic, and ecological failure into one simultaneous, visible catastrophe. The land didn't just dry out, it took flight. A 12-ton fire truck weighs about as much as 2 full-grown African elephants. A fire tornado can flip one like a cardboard model. That single fact tells you almost everything you need to know about what a pyrotornado actually is. During Australia's Black Summer of 2019 and 2020, these phenomena were observed across multiple states simultaneously, marking a threshold that researchers had been dreading since an earlier documented event near Canberra in 2003. A fire tornado does not simply appear wherever there is a large fire. It requires 3 conditions converging at exactly the same moment: severely desiccated air, high-intensity combustion spread across a wide area, and a specific pattern of atmospheric turbulence. When those variables align, superheated air masses rise at extraordinary speed and begin to rotate. The fire gets drawn into that rotation, and from that point on, the system feeds itself. This is the key distinction from any conventional tornado. A pyrotornado uses the fire as its fuel source. More combustion produces stronger rotation. Stronger rotation pulls in more oxygen. More oxygen intensifies the combustion. The loop has no natural break. Internal temperatures exceed 1000 degrees Celsius. The rotational velocity is not a rough estimate. It is a measured value at which engineered steel vehicles overturn. The column itself rises hundreds of meters, visually coherent, a defined spiral of open flame ascending into a smoke-filled sky. Around it, burning debris is flung outward across hundreds of meters, igniting secondary fires that expand the perimeter in every direction. Direction of travel shifts within seconds. No trajectory model is reliable. For firefighting crews, the protocol is unambiguous: immediate withdrawal. There is no tactical response to a pyrotornado, only distance. What ranks this phenomenon at number 4 among extreme natural events is not merely its destructive capacity, but its architecture. It is fire that has reorganized itself into a self-sustaining structure, operating by its own internal rules. A single hailstone the size of a grapefruit hits a car roof and punches straight through the metal. That is not an exaggeration. In Australia, it happens regularly. What makes this possible is not unusual violence from the sky, but a precise and terrifying atmospheric mechanism that turns ordinary ice into something closer to a ballistic projectile. Australian supercell thunderstorms rank 3rd among the continent's most destructive natural phenomena, and the science behind them explains why ordinary buildings and vehicles stand almost no chance. Inside a mature supercell, updrafts exceed 200 kilometres per hour. That sustained upward velocity keeps ice cores suspended for tens of minutes, circulating through layers of moisture and temperature. Each pass adds another ring of ice. The result is not a smooth, rounded pellet. It is angular, jagged, ridged, sometimes spiked, as though optimized for maximum structural damage. Hailstones can reach 16 centimeters across. When that irregular chunk of ice finally falls, gravity and terminal velocity push it past 100 kilometers per hour before impact. One strike equals roughly the force of a hammer blow. Now multiply that across thousands of impacts per minute per square meter, sustained over the entire footprint of the storm, and the arithmetic becomes catastrophic. Tiles are pierced cleanly. Tempered automotive glass, engineered specifically to resist shattering, disintegrates anyway. Solar panels, satellite dishes, and air conditioning units are stripped from rooftops in seconds. Parked cars emerge from a storm looking as though they were systematically worked over with a pneumatic drill. Sydney's April 1999 hailstorm remains one of the clearest records of what this damage looks like at scale. Losses were measured in billions of dollars. Queensland and New South Wales absorb these atmospheric assaults repeatedly every season between October and March, when supercell conditions peak across eastern Australia. The landscape left behind resembles a bombardment zone: buckled metal, pulverized glass, cratered asphalt, stripped vegetation. Giant hailstorms expose the fragility of constructed infrastructure with a particular directness. The damage is visible, countable, measurable in insurance claims. But where hail tears through what humans build, the next phenomenon on this list operates on a different target entirely, one that no policy can cover. The sky doesn't gradually darken, it folds. One half stays perfectly blue, while the other becomes a churning black mass with a base so geometrically flat, so surgically horizontal, that your brain refuses to classify it as weather at all. What you are looking at is number 2 on our list, the storm collar, or shelf cloud, and over Australia, it reaches a scale and ferocity that makes every other version of this phenomenon look like a rehearsal. Here is the paradox. The very feature that makes this cloud so visually impossible is also what makes it so physically precise. The mechanism is ruthless in its simplicity. A mature thunderstorm generates a powerful downdraft of cold air. That air hits the ground and spreads outward like a shockwave, undercutting the warm, moisture-laden air ahead of the storm front. At the exact collision line, warm air is forced upward rapidly, condenses almost instantaneously, and locks into that razor-edged horizontal shelf. The boundary isn't blurry because the physics doesn't allow for blurry. The atmosphere here operates in hard cuts. Australia amplifies this to its extreme. The baked interior of the continent produces dense, superheated surface air. Moisture-heavy systems push in constantly from both the Pacific and Indian Oceans. The thermal contrast is enormous, and enormous contrast produces enormous shelf clouds, walls that can stretch unbroken across the entire visible horizon, advancing at over 100 kilometres per hour. The minutes before arrival are measurable and violent. Temperature drops 10 to 15 degrees. Wind gusts ahead of the main front exceed hurricane thresholds. Atmospheric pressure shifts fast enough to register physically. Ears pop, dust columns rise, and animals retreat to shelter before any human has consciously identified the danger. Then the wall arrives, and day becomes night in seconds. Not minutes, seconds. The shelf cloud at least gives you a warning. You can see it coming. What ranks next on our list offers no such courtesy. It arrives from a clear sky, without announcement, at precisely the moment you are least prepared. Number 1 on this list will not bite you, will not sting you with a tail, and will not drag you underwater. It will simply stand there, looking gentle, and wait. That patience is what makes it the most insidious entry on our countdown. Dendrocnide moroides, the gimpy stinging tree, is a shrub native to the rainforests of Queensland, Australia. Heart-shaped leaves, a soft covering of whitish fuzz, an almost inviting appearance. The danger is completely invisible to the naked eye. Millions of hollow silica needles, each thinner than a human hair, each loaded with a neurotoxin called moroidin. The moment skin makes contact, the needles embed themselves, snap off at the surface, and begin delivering their payload directly into nerve endings. There is no clean removal. The needles are too small, too numerous, too deeply embedded. Survivors reach for extreme comparisons because ordinary ones fall short. Acid, electric current, both at once. A pain that does not fade after an hour or a day, but reactivates whenever cold air moves across the skin, whenever water touches the affected area, whenever fabric shifts against it. Documented cases describe suffering that persisted for months after a single encounter. Several recorded cases stretched into years. There is no antidote. The Australian Army recognised the threat formally, listing the Gympie as an official hazard in field training protocols. Soldiers were instructed not to touch it under any circumstances, not casually, not in full protective gear, not at all. But the most unsettling property of this plant is not what it does in the moment, it is what it does across time. Meteorite does not break down. It does not degrade with heat, age, or drying. Pressed herbarium specimens have triggered agonizing reactions in researchers handling them a full century after collection. The toxin is as potent in a museum drawer as it was the day the leaf was cut. This is where our list begins. 13 subjects, 13 reasons Australia remains the continent where inattention carries a price. The first was a plant that looked harmless and remembered every touch. What comes next arrives from above. A tree can cause pain that lasts for years from a single touch. That's not a myth, not a local legend, it's a documented biological fact from a continent where the extraordinary is simply the baseline. Australia doesn't scare by accident, it scares by design. Geological, biological, meteorological. Every single phenomenon on this list has been measured, photographed, and recorded. The reason comes down to isolation. Australia was left alone long enough for its systems to develop without interruption, without the moderating pressure of land bridges or competing ecosystems. 300,000 years ago, a meteorite struck and carved a crater nearly a kilometre wide. That scar is still there. Every September, a cloud 1,000 kilometres long rolls in on schedule, predictable as a calendar entry. Limestone spires push up through sand as if the earth is building something. One tree slowly strangles another over decades, methodical, patient, fatal. The sea turns red with living organisms. Fungi bleed something indistinguishable from blood. Waves arrive under clear skies. Pine cones fall with the force of a sledgehammer. Dust storms turn major cities into scenes from another planet. Fire doesn't just burn, it coils into a vortex and flips trucks. Hail punches through rooftops. A storm cell builds from horizon to horizon like a wall. 13 phenomena. Not 13 exceptions, 13 definitions of normal on this continent. No single one of them is folklore. Each has coordinates, timestamps, and scientific classification. Australia didn't try to become this, it just had the time. If this list showed you something you didn't know, hit like and subscribe. The next episode is already waiting.